Okay, so let's get started on last week's problem solution. And so first, when we do the audit probability problem, the first question you would ask, what is the sample space? What is the shape of the tuple we are counting? So what's the probability of that two top card in a shuffle deck are an ace and a spade? The ace cannot be used to satisfy both requirements. So basically, obviously, um, it's asking in a shuffled deck. So it's a single deck. I need to pick two cards.
You're
And
not sharing the screen.
oh, sorry. Let me get started. Really share screen. I think I already shared, is that right? I think I'm sharing because
Oh, I can't see it.
oh, you cannot see. Oh, I didn't click the share screen. It's right now. I should be seeing. You should be seeing it. Are you able to see it right now?
Yeah, I can see it.
Okay, that's good. Yeah, my fault. And so when you deal with a deck and you deal with a two card, so first you know the tuple is a double. So basically, it's the double we are talking about, and it's also a double without replacement. So no replacement, because you cannot put two cards, for example, you cannot do a double spade ace because one deck just don't have two of those cards. So basically, it's fairly clear that, we can, let's do it a order. So this is ordered, you know, ordered tuple. So basically look like this. And for example, each card will shape combination shape like heart 2 and diamond 1, diamond, like let's say that 7. So something like that. So it's going to be like 52 permute 2. So that's the denominator. And the numerator is what in favor. So we need to find out all the combinations satisfy the need. So the top two card in a deck. So basically, the top two cards are an ace of any suit and a spade. So basically, let's try to order it. Let's say that if I have a let's say that ace. More people knocking on the door. Let me see, how do I admit people in? Oh, I need to admit. Okay, I think I have to start sharing again. So basically, am I sharing right now? Are you able to see it?
Yes, I can see it.
Okay, yeah. So here, we will just have to find out all the combination, all the ordered sequence set. First two card has a ace and a like spade. So let's say that if I had, ace and the club ace and the diamond ace. So that's three possibilities. So let's, because it's going to be quite confusing so we kind of have to build a case right way. I think someone is knocking on the door, so I need to find out the way to admit people in. Let me see, how do I do that? Yeah, okay. I think, so right now, basically, we will have to, if we have heart A and club A and the diamond A, then we have the second card. This is the first card. And the second card, if we got any spade. then it actually works. So this is 13. So basically this is a 3 multiply 13. This is a sequence which works. Then basically we will get a like spade A, then the remaining will be like 12 spade. So basically this is also work. And then we have to think about in reverse. Think about in reverse is that we can actually do the heart A and club A and diamond A, then there will be spade. That's still going to be like, this is second position, this is the first position, a second position. That's going to be like, 3 multiply 13. And it seems like, a spade A here also works with the spade here. So this is still 12. So basically it looks like, on the top is 13 multiply 3 plus 12 and multiply 2. But we have to be careful because some of the combination actually are double counted. For example, let's trying to see the double counted thing. And here, basically, we care about what we care about: ace of spade, combination of ace, heart of the A and the spade A actually works in the first case, because first case we need a heart A and a spade A. So this is club A and spade A and diamond A and a spade A. So this is working case in this here. And this case is also a working case, somewhere here. So basically, we actually have the spade A cannot be used to satisfy both. This is the spade. Yeah, I think spade, this is the spade ace. Spade. And this definitely are different. Those are right. Those are right. And this is 12 case. Let me see if there's any duplicate or not. This is spade A, and those 12, and this is 12 aces. These looks like those are non-duplicate. Yeah. So, it's just this way is that 52 multiply 51, and then we will just try to, I actually did it once. So it's, let me see that this is like, this is actually 2 multiply 50, this is 51 actually. So basically, I think it's 2 out of 52 and 1 out of 26. This should be the answer. I tried to find any duplicate. I didn't really find any duplicate. So I think this is actually a complete one. Let me just try to do it, and then we'll trying to. So basically doing the problem is not about trying to, especially at this stage, is not about trying to get absolutely right the answer. It's just first trying to build the confidence in doing it. So basically you are doing a tuple, which really, so this is a ordered way. And let's see if we can do unordered way. So basically this is ordered pick. Then unordered pick, basically we can do the, And the unordered pick, you can also do the several different ways, is that it's 52 truths 2 on the bottom. And on the top, basically it is the choose the hot, then choose the so we can choose the hot like for choose 1. Then we can also multiply basically, 13 choose 1. So that's actually will, and we also need to minus one of those because we cannot, because spade A is one of those that, both will be included, because so here spade A cannot appear in both here and here, because that's, so on the top we actually have to minus 1. So if we do it this way, we're going to be like 52 multiply 51 divided by 2. And here it basically is 52 minus 1 and equals 51 over 52 multiply 51 and divide by a number equal multiply is reciprocal. So it's going to be like this way, going to be, 1 over 26. So basically, you have, so this way is unordered because, it not necessarily, hard is in front. And this basically, I'm trying to order things in the front and the back way. So basically, that's the way that you can do it. Then there's also use probability way. So I'm trying to present problem always in 3 ways. So basically, you can do it in the called ordered tuple. And then you also can do in the unordered set. Unordered set, then you can also do the probability way. Probability basically you dissect each step into a single event. So basically, we are choosing. So I think we are choosing a heart or choosing a spade. Choosing a spade is 1 out of 4. It's really. Then we also are choosing a heart. Choosing a heart basically is 1 out of 13. Choosing a spade is 1 out of 13. So choosing so that's then basically there are 2 ways of managing it. So basically that's the so when you choose when you yeah, this part basically is a little bit confusing. I think let's just ignore this part. So basically just do the previous 2 part. Hopefully it's right. And so this one, let's try to do this one. This one is for a lottery drawing a set of ball numbers through 1 through 9 is placed in each of the 3 bin. So basically a set of ball 1 through 9. So it's a 1, 2, all the way to 9. One ball is selected from, so it's placed in the 3 bin, 1, 2, 3. What is the probability that all 3 digits drawn will be odd? So yeah, so all 3 will be odd. So each bin, a set of ball number 1 through a place. So basically each bin will have 1, 2, 3, all the way to 9. So basically this is a pick without, or pick with repetition. So basically, you know, all 3 digit will be odd. So basically, you know, for here, so you draw 1, draw 2, draw first draw, second draw, and the third draw. Each draw basically will have the 1 through 9, basically you have 5 odd and 9 total. So basically for each draw is 5 nines. And if you do it all 3 times, it's, you know, all 3 digit will be odd, so that's cube. So that this will be the answer. And this one things, you know, this you actually separate as an individual. You separate the whole event as 3 individual event. So first bin is 5 nines, second bin is 5 nines. Then you can also view it as a 3 total event. Total event basically is the 3 tuple. It's a triple you are dealing with. So basically the total arrangement is actually going to be 3 to 9 to the third, because you know the way you put all the set together, you can go from 1 1 1 all the way to like 9 9 9. So usually, like, you know, the ordered set way is the most pure way that you can imagine that, you know, count the whole thing. And so that's going in 9 to the third. And the favorable way, basically, you know, the first being actually 1 3 5 7 and then 9. So basically it's odd. So basically it's going to be 5. You can pick from any one of those 5. So that's going to be 5 to the third over. So it's going to be reaching the same result. So this is just, you know, view the first method is probability way. The second method is like order tuple. And as everything, count it together. And this one is actually, you know, each spinner below is dividing to 4 equal sectors, and each is spun once, and the product is calculated. What is the probability that the product is positive? So basically, you know, again, I'm trying to do it in 2 ways. One is that we calculate the whole thing. So basically, there are 2 spinners. So basically, you can do like a, you know, the result going to be a double. The result is like spinner 1 and the spinner 2. And spinner 2, if you list all the combinations, just 1, 0, and then, something like that, all the way to like, say last one is 3, 2. And so you actually have the denominator different is 16. And if we just do the tuple, and then basically there are a lot of ways, so it's usually easier. We are only care about positive or not, so we can do this type of the problem, double event best used like a table like this. So basically, let's say spinner 1 and spinner 2, and spinner 1 and 2 basically we can do it this way is the most usually, especially the number is low. Right now, number is low. This is the most accurate way. And you can think differently than the other method. So S1 basically, let's say it's 1. And we only care about, uh, care about the product. And we only care about whether or not result is positive. So I write 1 here, it's positive. 1 is positive here, and negative 2 is negative, and then negative 4 is negative, and the 3 is positive. So basically, I got the spinner 1. Then spinner 2 is 0, negative 1, negative 3, and 2. So I got 0 and negative, negative, positive. So I only trying to do the negative, positive, and this is obviously 0, 0, 0, 0. It's not going to be positive. And here, negative, positive, going to be negative, 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 positive, negative, negative, positive, negative, positive, negative. So here, because I have a same sign, negative, negative, so I should be able to copy this colon plus, plus, negative, and this is positive, 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 negative, negative, positive, negative, negative, positive, positive, positive. So basically that's, I just want to count the positive grade. So 1, 2, 3, 4, 5, 6. So basically 6 out of, and this is going to be 3 over 8. So that's the probability. And we can also think about, each event way. So basically, this is kind of just, you use the double, use that total event. We can also like, this is spinner 1 and spinner 2. I think because we have because we actually have like here, positive, and so on the spinner 1, so spinner 1, we have positive and a negative, so we kind of do the branch. If it is positive, positive need to multiply positive to get a positive. So positive, the probability of S1 being positive is actually 1/2 because we actually have 2 equally like outcome out of 4 equally out of count. So it's 2 fourths multiply. And positive here, basically we have 1/4. And here is that negative is actually also 2 out of 4. And here negative is actually 2 out of 4. So basically this is 1/2 multiply 1/2 is 1/4. This is 1/2 multiply 1/4 equal to 1/8. So basically we add them together, it's going to be 3/8. We're also going to get this answer. So basically, either way you can get it. So this is we actually branch it. This is a complete, I personally like this better because especially for small numbers, small numbers, this actually, you cannot do it wrong because every result is very clearly outlaid. And so let's try to do this problem. And for a random selected phone number, what is the probability that the last 3 digits are all the same? So this actually, basically, if you view it as a probability event, all the previous digits actually do not matter, basically. A phone number has like 10 digits, like 3 area codes and then it's, you know, like it's on how the previous 7-digit is selected does not matter. So only matter starting from the, you know, the third digit counting from the end. And this number can be selected randomly because I can pick 0 all the way to 9 without any issue. And the first letter I'm picking it, I have no restriction. So it's 10 out of 10. I have 10 digits to pick from 10 possible sample. As soon as this was settled, the next digit has only 1 out of 10's probability. You know, because you can only fix it was fixated on that number, whatever number you pick. You cannot pick other number. So it's going to be like, you know, it's going to be 1 out of 100. So if you use the probability way, then basically, you know, if you, so this is the probability using the probability sense as the event. Then another way is that if you count the whole event, everything, so phone number as a whole set is actually a, it's called, you know, it's a 10 tuple basically. The phone number is a 10 digit, so basically it's a, actually you have 10 to the 10th power like way, assume you are allowed to select everything. Then basically, you know, you are able to freely select up to the first 8 because, so that's 10 to the 8th. Then the last 2 digit, it's already fixated. So you're going to get the same answer basically, you know, if you do it a 10 tuple. And so this is what is the probability that 2 cards in a shuffled card are consecutive card of the same suit. And so the top 2 cards, so basically still a double. So basically, you know, if you view it, it's a double event, 52 permute 2. And the consecutive card of the same suit. So the first card you actually is able to allow to select any card. So basically if you, it's a 52. And once you select that card, you can only pick a higher or lower. So basically, let's say that, yeah, so basically you are able to pick a higher or the lower card. For example, consecutive card of the same suit. So once I picked, for example, if I pick a diamond 7, then I'm able to pick a diamond 8 or diamond 6. Either way, then basically, you know, actually I can do the 2. And so basically, you know, if this is the way, basically 52 permute 2, that's going to be 52 multiply 51, and 52 multiply 2, that's going to be 2 out of 51. And let's also try to think in the suit. Basically, let's say that if you pick the diamond, let's say that both are diamond. Oh, let's say that let's say that pick the diamond suite. Diamond suit, what we'll do. So the way to do the diamond suit basically is the bottom is still 52 permute 2. Then the diamond going to be like, you need to pick a 13. You can pick one of the 13 card of the diamond. Then you can, the next card you have to be pick, diamond 6 or 7, you have to pick those two. So basically, that's the way that so basically that's the sand suit. Then diamond club, then basically if you accumulate, it's going to be the same. So basically this is the way that, I think it should be this number. So basically that's the probability, basically, the first card, because it's a free hand. So if you really think about it, using the probability. So this is using the double triple thing. And let's use the probability. The first two card, basically, actually you have no restriction. Whatever you pick will be fine. So basically it's 1 out of 1 or 52 out of 52, because if you, and the second card, in order this card need to be a consecutive card with the first one, and you only have 2 cards to choose from, basically, and the remaining card is actually 50, 2 card out of 51. The second card will be satisfying your need. So that's the way that I think will work. I'm not sure if I do it right or not, but I'm trying to present as whatever it is. So basically, if you are faced, because sincerely speaking, like counting problem, a lot of them are not that easy, and it's a challenge for anyone that try to do it. But basically, this is just kind of a best effort. Let's try to see what I did. If I don't share myself, let's see. So probability, we actually have the answer here, because today, so 3800 is actually 1 out of, yeah, it is actually 1 out of 26. So I actually did it right. And 1 out of 26. And the last step, I kind of, because usually if you do the counting method, you actually have a higher accuracy rate. What I find is that if you really complete count it, it's very hard for it to be wrong. And then there's basically, you have 1/4 of chance to select heart. Then you have 1/13th chance to select the, or you have 1/13th chance to select the heart. After you select that card, after you select that heart, basically, let's try to do it this way. For example, if I select heart, like diamond and club and spade, I have 1 out of 52 way to select that. Then the remaining, basically, I have 13 out of, because that's spade, I have 13 out of 13 out of 51 way to select the remaining cards. And I have to plus the, I have 1 out of 52 way to, this is select a spade ace. So this is ace, ace, ace. Then after that, I have 12 out of 51 way to select the remaining card. So basically, let's try to see if this works. So this basically going to be 4. And so this 3 multiply 4. I also going to cancel. I cancel this out. Oh, so this I'm going to cancel out 1 out of 17s. So 1, 4 multiply 17. And so this cancels 13. This cancels 17. Yeah, this actually do not add up very good. So I haven't really figured out how to do this just probability way, but counting sometimes I just find counting is a little bit more intuitive. So basically I'm going to, figure out that how to do that counting way later on, or probability way. So this is 3 to 1. Let me see if I'm right on those. 3 to 1 actually is right. So basically it's 125 out of 729. So this is actually the right one. And this one should be right. This one, because I did a complete count, because that actually, this I have high confidence. I don't think I will be wrong. And this one is also relatively straightforward. That's 331. Yeah, it's also 100, 1 to 100. This one, let's see. What I get is actually 2 out of 51. So let me see, 390. Yeah, 2 out of 51. Oh, happily, I actually get it all right. But anyway, this is just kind of the way that, you kind of can do it. And usually, I'm trying to present the following problem also this way, basically, especially, I present the problem several different ways if I'm able to figure out all the ways that do it right. And so let's get on to the next problem. And let's try to go as fast as possible this time. So we need to cover enough content to really do the work. So here is that, 3 dice roll 1. So basically, 3 dice are rolled. What is the probability that exactly 2 of the rows shows a 1? So basically, let's try to see that a dice basically is 1 all the way to 6. All the way to 6. And 3 dice basically, it's 3 of them will be rolled. And so basically, if we are, so let's try to do the tuple. So like 3 tuple, it's like a triple. So basically, if we count triple, the possible outcome is actually 6 to the third, because each dice are allowed to this much freedom to show up the result. And what is the probability that exactly 2 of the dice shows 1? So 2 of the dice basically is 1, 1. I can do 1, 1. If you're really trying to do it 1, 1, 2, and 1, 1, 3, 1, 1, 4, 1, 1, 5, 1, 1, 6. And you can also reorder it. You can like 1 on both ends and 1, 2, 1, 1, 3, 1. So basically, it's actually 1 multiply 1 multiply 5. So 1 is just itself, and 5 is the all the possible ways that you can arrange the other letter, other number. Then we also use 3 choose 1. 3 choose 1 basically is how many ways we can put, the non-1 number. We can put a non-1 number at the last dice or the middle dice or the first dice. So basically, if we do that, going to be like 15 over 6 to the third. It's going to be 3 multiply 5 and 2 multiply 3 multiply 36. So I cancel this out, going to be 5 over 72. So basically, if we count in triple, I think we got this. I'm sure this is right because that's a very clear count. So let's try to see how to do the probability way. Probability way basically, for each position, for example, the first position to get 1, you actually 1/6 chance. And for the second position to get 1, it's also 1/6 chance. And for the last position to get non-1, you got 5 out of 6 chance. So these are the probability for just one arrangement that put the non-1 number at last. And how many way we put non-1 number is 3 choose 1. So basically, we're going to get the same result, exact result, because still going to be 572. So this is the way that, yeah, so basically, yeah, so this one, the problem I show you is that it's doing the probability way. So, and so this one is at piggy bank. 5 coin out of 10. So 5 coin out of 10. So this is a, let's try to read a problem shake with 5 quarter and 5 nickel and 5 falls out. And so basically, let's try to see that how to make 85. So 85 cents, you have to make the 85 value with quarters and dimes, quarters and nickels. Yeah. So quarters and nickels. Quarter is 25, 25, 25, and 5 and 5. So that's going to be the way you make 85 cents. And to make this happen, basically, let's try to do several different ways. Is that if we do order the set, order sets, then its tuple is going to be like a quintuple, or like it's going to be five of those. So then the denominator is going to be like 10 permute 5. And the numerator going to be numerator because if you really analyze this problem, you got 5 quarter and 5 nickel. So we can label it like quarter 1, quarter 2, quarter 3, quarter 4, and a quarter 5. And this is nickel 1, nickel 2, nickel 3, nickel 4, and nickel 5. So the first, to make this combination, and here has no restriction, so 10 permute 5. And if we have to make 25, we need to first we face a task to pick 3/4 out of 5/4. So it's going to be 5 choose 3. We're also going to choose 2 nickel from 5. So going to be 5 choose 2. This just, we got coins. This is just coin selection. For example, we select 3 of those here. We select 2 of the nickel here. And then we are also, because this is ordered tuple, we need to think about, this is 1, 2, 3, 4, 5. And where I'm going to put a quarter. Quarter could be this way, and where we could put a quarter and a nickel. So we actually have like 2 ways to arrange that. Then we also have, and after we select the position of the quarter, then basically the quarter have 3 factorial ways to select it, and the nickel has 2 factorial way to select it. So we can try to calculate this problem. We know that actually 5 choose 2 and equal to 5 choose 3. Those are the same. It's very easy. It's actually 5 multiply 4 and 2 multiply 1. So actually, so these 3 number both actually is 10, because that's after we calculation, it's actually 10, 10, 10, and this is going to be 6, going to be 2, and 10, 9, 8, 7, and 6. So we cancel this one, and then we have basically the 8 could cancel all the 2. The 8 can cancel the 2 here. And so basically we got 5, 5. So going to be 25 over 63. So this is ordered tuple. Then the second way, let's try to do the unordered set. Unordered set, basically, you have like, the way to choose 5 coin out of 10, that's 10 choose 5. Then I need to choose like, I need to choose 3/4 and choose 2 nickel. Because it's unordered, it doesn't matter where I do the rest, so I don't have to multiply all the multiples here. It's going to be 5 choose 3 and 5 choose 2. And notice that, the count. So this is the count of the ordered set, ordered tuple. This is the count of unordered set. There's always a multiple relationship between here and here, the numerator part. So basically, and the numerator part here and here is also like has a multiple relationship, because actually, 10 permute 5 is actually, 5 factorial multiply 10 choose 5. So basically that's the way that they have a, so they actually have a like multiple relationship. So for this problem, um, I think if this problem can be reduced into a counting problem, you can always do it in the permute way. So permutation has more refinery, and then you can also do. And most of case you can also do unordered set. It's also going to come with the same result. So that's the way that you can do it. And here, if we calculate it, that's going to be like 10 multiply 10. And this we're going to be like, 10, 9, 8, 7, and 6. And then we're going to divide by factorial. Divide something equal to multiply its reciprocal. So going to be 5, 4, 3, 2, 1. And this going 2 and 3 cancel this, and 10 cancel this. Then basically we have the 8 going to cancel 4 and cancel the 2 here. So basically we're still going to get 25 out of 63. That's still the same. So we got ordered ordered tuple, unordered set. Then let's try to do the like probability way. Probability way, basically, we have to let's assume that we first quarter one. First, we're going to select a quarter. I don't know which quarter it is, but we're going to select quarter. Basically, all our quarter is labeled. All our nickel is labeled. And counting problem, even the quarter could be look like the same, but inherently they are actually different. And you have to treat them as different usually. For most of the case, you always have to treat it differently in order to get the right count. So basically, so we have 5 positions to choose. So this is 1, 2, 3, 4, 5. And let's say that position 1 choose quarter. What's the probability of that? That's 5 out of 10. Because originally you have 10 coins to choose from and you got 5 of them quarter. Then the next one still quarter is going to be like 4 out of 9. And the next one still quarter going to be 3 out of 8. Then I'm going to pick nickel because nickel has been never chosen. So I still have 5 nickel here, but total coin is 7. And the 5th position, I'm going to get 4 nickel because I already pick up 1 and going to be 6. So these are the probability. The probability of choosing nickel in the first, second, and the third position plus, or quarter, pick quarter in those 3 positions and pick nickel in the last 2 positions like this. But there are tons of ways. So I can do quarter, nickel, quarter, nickel. So I can do this way. So how many different arrangement order I can do those? It's actually 5 choose 2 because I only need to choose 2 position where I put nickels. So basically this is going to be the total result. And this going to be 10 choose 5 going to be 10, or 5 choose 2 going to be 10. So I can just simplify from here. So this is going to cancel this. And then 2 going to cancel 6 and has a remaining 2 here. And 4 multiply 4 equals 16. And 16 going to cancel 2 and 2 multiply 8. So on the numerator, I still 25 and this equals 63. So basically, that's the way that you are able to do this problem in 3 different ways. So, just trying to show that it's really important that do this. And so this is a compound event and accounting. And compound event is this is actually quite interesting topic. And so in the book, it's actually said that, this problem, you actually cannot count it. Actually, I have to disagree with it. Actually, you can count this problem also. So let me just show you how do you count this problem right. Because, so I'm going to present a counting way and also a probability way. So basically, Hank can hit the bullseye with bow and arrow with, 1 in 3 times. So basically, if you really look at it, 1 in 3 times, so basically you have 1 hit. Then you have a miss. And you have a second miss. So I'm going to, the 2 miss, I'm going to use a capital letter and the lower letter. But, for each event, because you hit 1 in 3, so the 2 miss basically just represent like 2 other equal chance that you could miss. Basically, if you treat it as this model, basically you actually you can simulate very well because they are not equal chance. You cannot use like capital H and a capital miss. Otherwise, it's going to be like 50%, 50%. because they are not 50-50. You have to add more letter to add more weight in the chance of the like miss. So if I think about this way, basically what we are going to deal with a night tuple because we are trying to find all the probabilities that you hit 3 arrow in night shot, and for those miss one it still count. So for a night tuple, basically, you actually got 3 to the ninth because each arrow shoot you could like using the equal chance, like hit, miss, capital miss, and lowercase miss. So basically that's kind of a simulation of what is represented by the statement. And then basically, let's assume the first is hit and the last 6 are miss. So basically I hit 1. So if I do the counting, hit, I have a 1 letter, 1 and 1. And for the miss, I actually have 2 letters. So it's actually 2 to the 6. So basically, if I really counting the tuples and equal chance tuple, this is a right model. And I have numerator 3 to the 9th and the denominator, 2 to the 6 just represent the first 3 arrow hit. But the way to choose the position of the hit actually is 9 through 3. So basically on the numerator, it's going to be 9 through 3 multiply 2 to the 6. So this is going to be, if I do it the counting way. And this actually, involve a lot of counting. Also, it cannot be canceled out very easily. So I'm going to use the calculator because otherwise it's just going to take forever for this calculation. And so I'm going to also show you how to use the calculator on the statistic function. Hopefully you all bought this calculator, because if you don't, then basically, especially at a higher grade, you actually at a disadvantage in terms of doing homework, or in terms of attending the test, because in the test, in the math test, especially in the SAT, actually, calculator is allowed, and they have a portion of test allow you use the calculator. They have a portion of the test do not allow you to use the calculator, and this problem definitely is in the portion allow you to use the calculator. So I'm going to also show how to use the calculator, even it's not allowed in AMC 8, but in other tests it's allowed. And also majority of the statistic problem you do have to use the calculator, because otherwise it's just very designed number, for the AMC. Really you can cancel it out. Otherwise the normal day you actually had to calculate it. So let me do this. And so this is just a complete screen of the calculator. And let's try to calculate this. So basically it's a 9 through 3 multiply 3 to the 6 and divide by 3 to the 9th. So let's trying to do this. So to call the statistic function, you can do just the math. Let me size it down so I can better present it. So basically when I click math, then show the function list. Then it's on the top bar, it's a probability function. So the math, number, complex, probability, and fraction. So it has a bunch of things. So you can choose, because I am doing the 9 through 3. So basically 9 through 3. So 9, this is permute, and permute, this is truth. So you kind of just can click the 3 here. You can do that. So it allow you to input a number. So 9 through 3, and then I'm going to be multiplying multiplying 2 to the 6. So 2 to the 6 Then I'm going to divide by 3 to the 9th. So this is just the chance of, I think somewhere I did wrong, 9, not 9 choose 9, 9 choose 3. So let me redo it. I don't have to redo it. I just have to multiply because 9 choose 9 is just 1. So I'm just going to multiply this result by 9 choose 3. So basically, actually, I can recall it back. I can recall it back and modify it. So basically, I can, so that's one advantage. You can use a calculator. Yeah, that's 0.27. So basically, that's the answer. And yeah, so 0.27. So that's the way. And actually work out some things that are going to, so this is a very fun topic here in terms of, because you know that, if you have one third chance to take the arrow right, and so here basically this is the counting way. So this problem I actually did it by counting. So this is just counting and simulate it. Then you can also do it. You can also do it by probability. The probability way is that, if the first letter or first arrow is hit and hit and hit, then you got miss, miss, miss. So the way to hit it is actually 1/3 chance and 1/3 chance again and 1/3 chance hit again. So basically that's actually 1/3 cubed. Then the miss is actually 2/3 chance. 2/3 chance you actually has, this is actually 2/3 to the 6. Then you have like 9 choose 3 way to really position which arrow you're going to hit it. So if you do that, that's going to be like, it's going to be the same answer. So it's going to be 9 choose 3. Yeah, 9 choose 3, because it's going to come up with the same fraction, because 9 choose 3 is still the same. And here, if I'm trying to simplify it, if I try to combine the like index, the denominator going to be 3 to the 9th, and the numerator going to be 2 to the 6th. So basically, it's going to come up with the same result. So that's the arrow hit. And the arrow hit. So this is some extension of this topic a little bit, because it's very interesting thing to really think about it. So because you have 1/3 chance to hit a single arrow, and so when you shoot any arrow, it could be either hit or miss. And when you shoot 9 arrow, actually hitting just 3 is actually a minority. It's not, it's not really stick to your intuition that it's 100% to hit 3 arrow. Actually, this is far from the truth. You actually has the chance to hit any number of the arrow. You can hit 4 arrow, you can hit these 3 arrow, you can hit 2 arrow, you can hit 1 arrow, you can hit 0 arrow. You can also hit 5, 6, 7, and then 8 and 9. You even your chance to hit 1 arrow is 1/3. But if you are on good luck, you actually have the chance to hit all 9 arrow. So this is actually putting some time to really calculate the probability of hitting different number of the arrow. So hit 9 arrow hit 3 is still have the highest chance, but hitting 4 arrow you have 20% of the chance. If we do the math, it's very similar. 1/3 going to be to the 4th power and 2/3 going to be 5th power. Then multiply how many 4 arrow position I'm going to choose from the 9 arrows. So that's going to be, you can just modify it. You can in the calculator. Well, this is what I did on the calculator, kind of just backspace and modify the number a little bit, you can actually calculate them all out. Then this is 4-arrow chance 20, 2-arrow chance is 23. So it's actually easier to miss than you know. And so this is actually 4 arrows. The 2 arrow has a slider. Then hitting 1 arrow. So this is 2 arrow, 1 arrow. So if you really think about it, and this is also hit 0 arrow. Hit 0 arrow, you have about like 2%, about 2.6%. If you add them up, basically that's going to be 30. So this is 30, 23, 11. So going to be 34, 35, 35 plus 35% plus about 2.5 is about 37%. So basically you have about 37 chance of the 37 percent chance to like miss. And then score lower than 3 arrow. Then you can also like 4 arrow is 20%, and 5 arrow is 10%. Then 6 arrow is only like 3%. So three arrows probability is about equal to the hitting 0 arrow, and 7 is less than 1%. So and 8 is really, really low. It's this is about like 7 out of 1,000. This is about 1 out of 1,000. So this is about hitting all 9 arrow. You are really, really lucky. And so this is actually 5 divided by, so it's actually 1 out of 20,000 chance to hit all 9 arrows if you have that kind of the skill. If you have a low skill but have super good luck, you still has the chance to hit 9 arrow. So it's yeah. So and so basically if all those probability adds them up, it's going to be 100% because you will hit from 0 arrow all the way to 9 arrow, and so this -1 and the minus, yeah, so this going to be so basically hitting for all the probability hitting less than 3 arrow is seems to be a little bit higher than all the probability that hitting more than 3 arrows. So basically, this kind of the like phenomenon that like the phenomenon like you're more likely to have a bad luck in a test, because if treat each test as the probability that you could score certain point, but there are some probabilities that scoring lower actually a lot of case it will be different in each cases, but you actually can try to calculate it. It's actually it's actually very rare that to get a super good luck. It's just more chances to hit a lower score by this model. And so this one, so this one is a very interesting problem at arrow hitting. And we actually do it in two different ways that convert this problem into a counting problem. So and this type of the problem, you're still able to convert like one. If it's in an integer ratio, it's still possible to convert into a counting problem because it actually will come up with the same result, same number. But it's going to be impossible to convert into a counting problem if you are faced with a very, for example, a likelihood of the numbers that down to like 4 digits. Otherwise, you're going to design a fraction that's so big that calculator cannot even do it with right. So you have to use the probability. So somewhere around here, you really need to get used to like getting comfortable with just dealing with probability only and alleviate from yourself on counting things at some point. And then this is the problem that, there are a dozen eggs in a basket and 4 have been hard boiled. You can tell by spinning the egg where it has been boiled. You select 3 egg from the basket. What is the probability that only one of these 3 is hard boiled? So here, you have a dozen of the eggs, so you usually, and boiled, so basically it's a boiled egg. So you have 4 boiled, so you have say B1, B2, B3, and the B4. So this is the model you're trying to build. And then you have a dozen, so obviously the remaining 8 is not boiled, so those are raw egg. So you can say that R1, R2, and all the way to R8. And it's asking you select 3 egg from the basket. So 3 egg, what is the probability one of them is hard boiled? Only one of the which, so only one. So basically, only one. So what we are dealing with is a, obviously it's a triple because the result set is 3. So let's try to do the permutation. So permutation, basically, the denominator is that it's a non-replacement, 12 pick 12 permute 3. So basically the denominator is 12 permute 3. That's all the way that you can put in an ordered set without replacement. Then basically, I need to choose one egg out of those 4. So I'm going to choose one. Basically, I have to assemble a team which made up 1 boiled egg and 2 raw egg. So I'm going to assemble the team like 8, choose 2. And these just choose member. I need to choose the position because I'm counting the ordered way, counting the ordered tuple. Everything is if denominator is ordered, then the numerator also need to be ordered. So basically, I can do like raw, boil, raw, and boil, raw, and so basically, these are the ways that I can arrange the position of those 3. So I'm going to 3 choose 1. So that's going to be the number. And then within those 2 raw egg, I can swap the position. So basically, those are the order way. So that's 2 factorial. And the boiled egg is just 1. So you multiply 1 factorial, but it's already trivial. So we don't really do that. So that's going to be ordered way. And let's try to do this problem. 3 pick 1, 3 choose 1, 3 multiply 4 multiply. This is going to be 8 multiply 7 divided by 2. Divided by 2 going to be just cancel 1 out. So it's going to be like this way on the top. On the bottom, it's going to be 12 multiply 11 multiply 10. And let's cancel this 12. And so there's extra common factor I can find. So there's 2 multiply 5. This is 2 multiply 2. I'm going to cancel out one of the two. So I am going to get like 55. Then this is going to be like 14. So yeah, so let's try to do the other way. So this is ordered way. So let's try to do unordered. And unordered, basically, it's 12 through 3. And then I only need to care about, how to choose the egg. And 4 choose 1 and 8 choose 2. And that will be it, because that's only one of, so this is exactly one of those. So this is 4 multiply, I already calculate this is 4 multiply 7 and 8 choose 2. And this is 12 choose 3 is 12 multiply 11 multiply 10 and divide by 3 factorial. Divide by saying is multiply is reciprocal. Basically, that's going to be 3 factorial here. 3 factorial is actually 6. So I'm going to put it here. So let's try to cancel those. And this is 4. I can get a 3 here. And 3, I can cancel this, get a 2 here. And 2, I can cancel this, got a 5 here. So this is going to be like 55. And this is going to be 55. This is going to be 28. So basically, I actually have a matching result. Somewhere either this is wrong or either this is wrong. So somewhere I did it wrong. So basically, we kind of just going to figure out where I did it wrong somewhere. I think this egg problem, I think this will be 12 choose 3 and 4 choose 1 and 8 choose 2. Yeah, in this case, actually unordered seems to be more convenient. So basically this has higher likelihood of being right. So let's try to examine that again. 4 choose 1, just 4. 8 choose 2 is 4 multiply 7, that's right. And here is 12, 11, 10, and multiply 6. Let me try to do it again. So basically this is 12, 11, and 10, 4, 4, 7, and 6. And so this going to be 2. This going to be 2. This going to be 5. So 28 and 55. I think this might be right. Let's also try to use the probability way. Let's try to do how do we do the probability way? Probability way obviously is that we actually, so we actually have 3. So this is more kind of display of different arsenal you have. And then we will try to, so we can have the, like this is the model is that 8 raw and 4 boiled. So let's say the first egg is boiled, then the next 2 is raw. So if it's arranged this way, then I pick the first one boiled is 4 out of 12. And then I got raw, basically it's 8 out of 11 multiply 7 out of 10. And this basically I have to permute 3 times because I can put where the boiled is. So let's try to calculate this. So 3 choose 1 is just 3. So basically I can actually cancel this. And then I can try to cancel this is 2 multiply 5. This is going to be 2 multiply 4. And I'm going to cancel this, going to be 28 of like 55. So looks like the unordered way and this should be winning out. So let's try to check ordered way where I did it wrong. So basically, this is how many ways we pick the, for egg. We also task with how many way to pick the, how many way we pick the raw egg. And this is 3 way within the 3 position. That seems to be right. And then 2 factorial, that also seems to be right. Let me try to redo it somewhere. This is 3 multiply 4 and multiply this choose to going to be 4 multiply 7 multiply 2 and 12 multiply 11 multiply 10. This cancels. And this cancels this. Actually, is right. Yeah, this is also right. Somewhere I made calculation wrong. Somewhere when I was canceling it, I didn't really cancel it right. So basically, it's actually all right. So basically, this is just different way you can think problem differently and still get the right answer. So then let's see. Yeah, it is this way. So basically, it's just multiple ways that you can think about it. And I think the problem from this section is quite classic. I think you kind of just have to take time to soak in and really really trying to understand the underlying mechanism in each method. So basically, I hope you master all 3 different methods. So at least you actually has multiple tools to check them and view it at different angles. That's going to be helpful in terms of like, managing the probability problem. Then let's try to do this problem. And so Oleg rolls a standard 3 die 3 times. What is the probability that third row is greater than the sum of the first 2 rows? So basically, this type of the problem is actually, you have to do it the casework because it's actually a very complex event. You imagine, if you roll a 6, there's no way in the first row, there's no way you can have a third row that, bigger than both first and second. So we actually have to casework that, like, let's build up from the lower end. For example, the third, the third die. The third die if it's equal to 1, there's no way that it will happen. So the count is 0. And third die, if I roll 2, It's still going to be 0 because, it's saying that the third row is greater than the sum of the first two rows. The first two, the minimum number is 1 plus 1. So 2 is also 0. Let's start from 3. And if we do the 3, then 1 and 1 is one of the possible way. So 1 and the 1 as the first two row. And if we do 3, 4, the last one is, so basically first we also trying to see the sample space. The sample space concept is really important. And here we roll a standardized 3 times. So the only possible way you can get on the denominator is 6 to the third. Because this is just, if you do a complete list, how many ways you can lay out those 3 numbers. And then so this is the third number, the third die, what that number will be. If it's 4, how many case? So this is like a tree diagram. So this is a tree diagram, for example, I can build event and this tree is not symmetric. So you can only like count the tree branch. You cannot multiply. And so on row 4, basically you can get 1, 1, and you get 1, 2, and you got 2, 1. So basically you have 3 case. So this is 1 case, and this is 3 case. And if you do 5, then all those 3 will work. So this is working. So all 1, 1 will work for row 3, 4, 5, and 6. So basically it all works. But we trying to count, so basically it's 3 plus. We're trying to find out all the compatible ones. The compatible one is actually in the new compatible list is that the 2 rows sums up. This is sum up to 3 max, sum up to 4 max. Sum up to 4 max, basically you can do 1, 3, and 2, 2, and 3, 1. So basically it's 3 plus 3, so equal to 6. So you have 6 of those. Then if you the third dice roll 6, then these 6 case all work. 1, 1, 1, 2, 2, 1, 1, 3, 2, 2, 1, 3, 1. Those 6 case all work. So basically is equal to 6 plus. And the new cases that work with 6 is that it's actually the new one is 1, 4, and 2, 5, 1, 4, and 2, 3, and 3, 2, and 4, 1. So basically those are the 4 cases. So plus 4 equals 10. So we got 10, 6, 3, and 1. So these are like 20. So we have 20 cases which it will work. The probability, so this is the favorable, and the all is 6 to the cube. And so basically, let's just factor. And this is 2 multiply 3, 2 multiply 3 multiply 6. So I'm going to cancel this 2 out. 5, 6 multiply 9, 54. So that's going to be the chances that, let's try to check if that, yeah, 5 out of 54. So that's the way that you can do it. Let's try to keep going on. And so this problem is that 5 boys and 7 girls are randomly assigned to 3 groups of 4 students each. What is the probability that one of the 3 group will be all girls? So basically we still start the problem by labeling the sample data. So 5 boys, so boy 1, boy 2, and boy 3, boy 4, and the boy 5. So that's girl 1 and the girl 2 and the girl 3. Go for girl 5, girl 6, and girl 7. And we need to use 3 group. So basically we have group 1, group, and those are 4 students each. So basically, I need to put in the letter in those baskets. And this problem actually we have to depend on the symmetry of the data, because it's asking the probability that one of the 3 group. So I'm going to calculate what's the probability of the first group will be all girl. So we going to first group all girl. And then we're going to multiply 3. Why multiply 3? Because you know, the first group has this probability, and the first group is non-special because it's just, I call it the first group, and you can actually call any group first group. So it's all the same. And so because the account is the same, they are symmetric. So what we are doing is that so if we only concern about the first group, so the data shape going to be a quadruple. So it's going to be a set, like, have contain 4 letters, for example, B1, B5, girl 1, and the girl 7. That's a legit tuples for this, the end result. And the total count with ordered setting on the ordered environment is actually 12 permute 4. And the way that it's all girl, so if I need to choose girls to fill in the first group, I have 7 permute 4 ways, because I need to pick candidate only from those subset. And in ordered way, it's 7 permute 4, because we actually have 3 position to assign first group. So it's going to multiply 3. So that's the way that we're going to tackle this problem. And then we expand it, going to be 3 multiply 7, multiply 6, multiply 5, multiply 4. And this is going to be 12 multiply 11, multiply 10, multiply 9. So we began canceling this. And we cancel this to, and we also have cancel 2 with a 3, cancel 3 with a 3. So basically, looks like everything got canceled all out except 7. And on the bottom, basically it's 3 multiply 11 going to be 33. So 7 out of 33. So this is, we are counting the tuples. And then we can also do the probability. Probability basically, let me use a different pen. Probability basically, we have the 4 position, and if it's all girl, then it's going to be 7 out of 12 multiply 6, 11, and 5 out of 10, and 4 out of 9. So that's the probability to choose all girl for the first group. But we have 3 group. It's symmetric, so we're going to get multiply 3. So we can actually cancel this way. and 2 and 3 and 3. And we're still going to get 7/33. So that's the way that, yeah. Let's see, yeah. So basically, we actually have different ways. So this problem is actually using the letter, the 26 letter of alphabetic are placed on tile and randomly separating to 2 equal piles. So basically, we have 26 letters and 2 equal, and one is 13, the other is also 13. What's the probability that the word mass be found in one of the 2 pile? So basically, this problem is dealing with 13, so it's actually 13 tuple. And the way to, get 13 tuple count in order, this is ordered matter is ordered tuple. And it's very simple. It's just 26 permute 13. And then the mass will be found in one of the pile. So the mass, to get the mass, I need to pick all those 4 letters. So basically, it's going to be like 4, choose 4. Then for the remaining, it's a 13 tuple. So the length of the tuple is very important. You not just pick those 4. You need to pick the remaining 9 because 13 minus 4 equal to 9. So the remaining 9 letter I am going to do the I have to choose from 22 of those letters that not math, M-A-T-H. So basically, I'm going to 22 choose 4, or 22 choose 9. And 22 choose 9, because this is order set, I'm going to choose like 4 letter position for the mass. 4 letter position out of 13. So this is, then we actually, after we choose this, we also need to, within the 4 letter mass, we're going to, multiply it. We also need to multiply the 9 position. Within the 9 position, the 9 letter, we also have to do this. So this is actually quite complicated. So a lot of time when I'm doing the ordered tuple, I kind of just put it there just for reference. And I usually will just, do the unordered set. Unordered, basically, it's 26 through 13. And so I have no obligation to order them. So I only need to pick letter. So it's much simple. I have 4 pick 4. I had to pick for all 4 letter mass. That's absolutely needed. Then for the remaining letter, I'm going to just do the like 13. Actually, I'm going to 22 choose 9. So that's the way. And I think that's it. Could be one of those. Yeah, this is the probability that one of those has 4 letter, because I have 2 group. This is 2 piles, so I think I need to multiply 2. I need to multiply 2 because it's symmetric. So basically, and I also need to multiply 2 in the ordered tuple. So here we can begin to calculate, and 22 choose 9. I think it's a very big number. I think let me use calculator. I don't think I have the time to really do it. So basically, I think it's also good to, like, for bigger number, it's just, it will, I think will be like this, if I write into the calculator language, it's just to multiply, like, 22 choose 9, then or divide by um like 26 choose 13. So this is the number. Let's try to do it. So this way I am able to arrange my real estate in screen to properly display the calculation of what I'm supposed to do. And so that's going to be 2 multiply. And you can also do the alpha window. Alpha window also will get alpha window is actually have less keystroke. And so, and the choose function is on the 8. So you click 8. And so that's going to be 22. And choose 9. And I'm going to divide. So it's multiplies and going to divide by an alpha. And that's 8. 26 choose 13. Yeah, so this one, and one of the advantage of TI calculator, you actually is able to convert into the fraction. So let's try to do that. So you can alpha y, and then this is the fraction decimal. The first function is the decimal and fraction conversion. And so we actually 11 over 115. So basically we actually convert it back to 11 over 115. Obviously this has a lot of cancellation, so it's possible for me to do it. And even calculate. Let's see if we did it right or not. Yeah, this is actually right. So basically, and then we can also do it a compound probability. So this is just pure counting. Pure counting. So it's not even doing any probability. The final result is probability, but it's just treason as the treason as the whole tuple thing, and then trying to. So this is unordered. Let's check the ordered. Ordered basically, we can also do the calculator. It's 2 multiply 2 multiply 13 choose 4. and multiply 4 truths for trivial. I'm not going to do it. So this is 22 truths, 9. Truth and the 4 factorial. Oh, I think somewhere I actually did it wrong. So 4 factorial, let me do it this way. So 9 multiply 4 factorial, also need to multiply 9 factorial. Multiply 9 factorials and also divide by 26 permute 13. And 7. Yeah, so this actually come up with the same number. So basically, we actually also get the permute calculation right. So we still can do this trick to convert this fraction to, or this decimal into fraction and 11 over 115. So here, so it's a ordered tuple, unordered set. Then finally, let's just do the do the probability. So probability basically the mass find in one of the two pile. We're still going to imagine the position that, let's say the first 4 letter are going to be mass. So first 4 letter is one of the mass. And then basically it's going to be 4 out of 26 multiply 3 out of 25 multiply 2 out of 24 multiply 1 out of 23. Then the remaining 9 letter, because we are going to put on a remaining there's no non-mass. Remaining there's no mass letter. The remaining are all non-mass letter. So it's 22 out of 22, then 21 out of 21, all the way to like, because it's actually 26 divided by 2. Yeah, then it's 14 out of 14. So basically, if you do it, it's going to be, and these are trivial. So basically, we got this as the probability getting the 4 letter as mass, because in a single group, I have 13 position to pick for the mass. So basically it's 13 choose 4. 13 choose 4 and multiply this probabilities, and because this is just one group, we are calculating the probability for first group. We have 2 equal likely group. So we're going to multiply that. Yeah. So this one is a relatively easy thing. So basically here, 13 choose 4 is just 13 multiply 12 multiply 11 multiply 10. And this is 4 multiply 3 multiply 2 multiply 1. And here we actually cancel out that's perfectly. Multiply 4, 3, 2, 1. And so basically that's going to be 26, 25, 24, 23, and multiply 2, everything. So this we actually can cancel out 2 and 25. We're going to cancel out this by 5. And so because we have a extra 2, so we're going to completely cancel all the 10. And this is 12 going to cancel out 24, going to get 2 here. And also there are 2 going to cancel out this 2 here. So on the bottom, it's going to be 2 multiply or 5 multiply. So that's going to be 115 and that's going to be 11. So this also is right. So we also use probability to solve this problem. And I think this one is also easy to cancel. I kind of just choose to use the calculator. But I mean, if you usually operation with the factorial are quite easy to cancel. So most of the factor you can cancel it out. It's relatively easy. But anyway, you know, it's just whatever method you are using, just trying to show you whatever method you are using, if you just do the calculation right, you will always get the same answer. And there's pretty much, it always has a 3-way order tuple on order set plus the probability event. So these are, you know, this method is just piggyback each probability event into multiple steps. So each step you get a probability, then trying to combine them together. Okay, I think that's all for today. And next time we will finish up the remaining. There are not much on the remaining. Then we also have the number theory, and we'll try to do as much as possible. Then we'll assign the homework after the class. And thank you. Have a nice one, everyone.